Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of lines. So as per the problem, for each pair of lines, determine the size of the acute angle to the nearest degree that is created by the intersection of the lines. So let's start with the first pair. In the first pair of lines, the first equation is in parametric form and the second equation is in vector form. Now we know that the angle between the lines is equal to the angle between their direction vectors. So we should find the direction vectors of these two lines. So let's start with the first equation in parametric form. The components of direction vector are equal to the coefficients of t terms in the parametric equations. So in the x equation, the coefficient of the t term is 2. So the x component of the direction vector is 2. In the y equation, the coefficient of the t term is -5. So the y component of the direction vector is -5. So this is the direction vector for the first line. Now in the second line, the direction vector is the vector with the parameter t. So the direction vector of the second line is -4, 1. Now we can find the angle between these direction vectors using the dot product equation. Now we can use these vectors. For the magnitude, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. So for the dot product, we multiply the x components and y components. On the right side, we can square the terms under the square root and add them. So 2 square is 4, -5 square is 25, and 4 plus 25 is 29. Under the other square root, -4 square is 16, and 16 plus 1 square is 17. Now we can simplify the expression on the left side. Now we can multiply square root of 29 and square root of 17. Next, we can divide both sides by 22.204. So we get next we can do the inverse of cos. Now we can evaluate the inverse of cos. I get almost 126 degrees. So this is the angle between the direction vectors. Now this angle is an obtuse angle because its value is between 90 degrees and 180 degrees. But in this problem, we have to find the acute angle, and for that, we have to subtract 126 degrees from 180 degrees, which is equal to 54 degrees. So that's the acute angle between the first pair of lines. So this should be the final answer for the first pair of lines. Now we can analyze the second pair of lines. In the second pair, the first equation x equals 3 represents a vertical line because the equation is given in the form of x equals a number. For a vertical line, the slope is undefined. The formula for slope is rise over run. The slope is undefined if the run is equal to 0. So one possible values for rise and run for slope to be undefined is 1 over 0. And we know that rise is in the y direction and run is in the x direction. So the direction vector for this line is 0, 1. So we use the run number for the x component and rise number for the y component. So this is the direction vector of the first line. Now we can analyze the second line. The second line is given in Cartesian form. We can reduce by dividing each term by 5. We can get the normal vector of the line from the Cartesian form, and the normal vector for this line is 1, -2. These are the coefficients of x and y terms. We can use this normal vector to find the direction vector of the line, and for that we have to flip the components of the normal vector and change the sign on one of them. So we can change the sign on 2. This can be the direction vector of the second given line. Next, we should find the angle between these direction vectors, and that will be the angle between the lines. So for that we'll use the dot product equation. For the magnitude, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. We should multiply the x and y components. Zero square plus 1 square is equal to 1, and square root of 1 is 1. 2 square plus 1 square is equal to 5. On the left side, we can simplify the expression. Now we can divide both sides by square root of 5. Next, we can do the inverse of cos. Now we can evaluate this inverse of cos. So I get 63 degrees. I rounded the answer to the nearest degree. So this is the acute angle between the direction vectors. So this should be the final answer for the second pair of lines. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.